Okay, today's topic is highway alignment. Okay, now we are covering the theory portions of the highway engineering or transportation engineering as the name of your proposed subject for the fifth semester. So, in transportation engineering, and basically from the beginning, some theories are there. Uh, at the starting portion, what you have seen, some historical things are involved in first chapter. So, how where our road has been started to construct, how the measurements have been taken for construction. After that, now we have to go through our highway engineering portion. Okay, before going to highway engineering or the geometric, actually the technical terminology is the geometric design. So before going the through the geometric design, we have to go first for the about the alignment. What is the alignment, highway alignment? What is the surveys are involved in to maintain this geometric design as well as the alignment. So highway alignment and engineering surveys are also involved in your geometric design part. But before geometric design, we should study the highway alignment, engineering surveys which are involved in your highway geometric design. Geometric design, one of the important part in highway. Lots of numericals are involved in geometric design, and it can be seen that on always we are being seeing that the from geometric portion normally 70% questions normally come, okay, from the geometric section. But before geometric section, we should study the highway alignment. It is also theory portion, but it is necessary to understand what is highway alignment, what is geometric design. Okay, so what is highway alignment? Highway alignment, I have written one sentence that the position, listen carefully, the position or the layout of the center line of the highway on the ground is called the alignment. The position or layout of the center line of the highway on the ground is called the alignment. The horizontal alignment includes the straight path, the horizontal deviations and curves. Changes in gradient and vertical curves are covered under vertical alignment of roads. So in alignment there are horizontal alignment include the straight path, the horizontal deviations and curves, and changes in gradient and vertical curves. There is always curve in your road. When we pass through the road, we observe these curves because due to our earthen surface, the nature of earth surface, the nature of the topography, nature of our terrain. Terrain is same as our nature of the earthen surface. Earthen surface is called terrain, and also the topography. Topography also the nature of the earthen surface or the characteristics of earthen surface. So lots of factors are involved in this for cars actually in our alignment, our highway alignment. So the changes in gradient may be up gradient, maybe down gradient, some hilly areas, some fluctuated areas, some or any mounted areas. The changes in gradient and vertical curve, that is hilly area. Vertical curves are covered under vertical alignment of roads. This is the basic thing of highway alignment. The position or layout of the center line of highway on the ground is called alignment. A new road should be aligned very carefully, as improper alignment would result in one or more of the more disadvantages. What are these disadvantages? Increase in construction cost. if my alignment is not correct, is not proper, there should be increase in construction costs. Number one. Number two, increase in maintenance cost. Our work, not only the construction, also maintenance part is also our work. We have to maintenance after construction. Third, increase in vehicle operation cost. Okay, this is the general cost involved in our vehicle who are dealing with the vehicles. The increase in vehicle operation cost. And number four, increase in accident rate, which is not accepted. Okay, increase in accident rate. Once the road is aligned and constructed, it is not easy to change the alignment due to increase in cost of adjoining land and construction of costly structures by the roadside. So once the road is aligned and constructed, it is not easy to change the alignment. It is true. Due to increase in cost of adjoining land and construction of costly structures by the roadside. Obviously, to acquire the land is very difficult when we are constructed any road. Suppose you have heard lots of news from news channel or from newspapers that acquisition of land for road work is very difficult. Okay, nobody is ready to give their lands for roadway, but once the road is aligned and the construction, it is not easy to change. Not only the acquisition of road or adjoining land, also the construction, heavy structures which are already built by the roadside. So it is very important, before construction the highway, alignment should be correct. Okay, hence the importance of careful considerations while finalizing the alignment of a new road need not be overemphasized. Okay, after this alignment, some introduction of the alignment, which are the points to be covered under this highway alignment. In your syllabus, the requirements part has been omitted in new syllabus, but there is one part, that is requirement of highway alignment or requirements of highway alignment. Actually, the basic requirements, I have kept these points under the requirements section. The basic requirements of an ideal alignment between two terminal stations. Okay, suppose point A to point B. Suppose Durgapur to Asansol. Okay, Durgapur to Asansol, you have to construct a new road. For that purpose, Durgapur and Asansol is the two terminal points in our highway engineering language. Two terminal points, Durgapur and Asansol. So, the basic requirements of an ideal alignment between two terminal stations are that it should be short. Number one, short. Number two, easy. Number three, safe. And number four, economical. Short, easy, safe, economical. Okay, economical, you know, economical, always we think about economical, which should be economical, which process should be economical, which method should be economical. Safe, always there should be some safe construction procedure, always there should be safe vehicle movement facilities. And easy, it should be easy to reach one point to another point, one terminal station to another terminal station. And it should be short, because short journey is always required to reach from one place to another place. And if we go details through these points, suppose short, we can say it is desirable to have a short or shortest alignment between two terminal station. A straight alignment would be the shortest. There may be several practical considerations which would cause the deviations from the shortest path. Okay, so it is desirable to have a short alignment between two terminal stations. A straight alignment would be the shortest, though there may be several practical considerations which would cause deviations from the shortest path. We will discuss which these deviations, which this shortest path about which we are concerned. Okay, then easy. The alignment should be such that it is easy to construct and maintain the road with minimum problems. Also, the alignment should be easy for operation of vehicles with easy gradients and curves. Okay, so there should be less gradients, less curves to maintain our road in a straight path, in a straight route. There should be less gradients, upper gradient, lower gradient, or curves. Curve section should be minimum as much as possible. Safe. Next point, safe. The alignment should be safe enough for construction and maintenance from the viewpoint of stability of natural hill slopes, embankment and cut slopes, and foundation of embankments. So the stability of natural hill slopes, there should be stable land, because if your land is waterlogged land or some marshy land, so it is very difficult to maintain your road, because in rainy season, if water moisture is harmful our road. Okay, so because our total road construction depends on one formula of soil mechanics, that is density. If the density of the subgrade is okay, that is made from soil, this density is okay, then our road is okay. If the density of the road is not okay, or the subgrade soil of the road is not okay, then my road is not okay. Then that means if I give lots of money for my top layer, my middle layer, but I have not taken so much consideration, so much things, so much thinking on my subgrade, then my road is not is stable. Okay, so I should take some decision where my road will be constructed. So viewpoint of stability of natural hill slopes, embankments and cut slopes, the foundation of embankments. Also, it should be safe for the traffic operation with safe geometric features. Okay, about geometric features we will discuss in geometric design. Economical. The road alignment could be considered economical only if the total cost, including initial cost, maintenance cost and vehicle operation cost, is lowest. So 3 points should be is our concern, that is initial cost, maintenance cost and vehicle operation cost, and these three costs should be lowest. All these factors should be given due considerations before working out the economics of such alignment. And the alignment should be such that it would offer maximum utility by serving maximum population and products. Okay, the utility should be high of this road. Okay, we are suppose I am constructing a road, but the utility of the road is very less. Lower people from the two terminal stations, they will use this road, because this road is not shortage, or this road is not very easy to movement for their purpose. So if the utility of the road is very high, then my purpose is successful. Okay, so maximum utility by serving maximum population and products means goods. Vehicle which carried the goods, uh, that vehicles should be high, that types of vehicles should be high for utilization of the road, and also the population who actually for whom we are for whom service purpose we have constructed the road, that much of utility should be there. And the utility of road should be judged from its utility value per unit length of the road. Already this portion utility, number of numerical problems are involved in utility, which things have been already excluded from your new syllabus. Okay, utility per unit road, there is number of problems, there is number of numericals related your utility per unit length, but in new syllabus it has been excluded. Whatever, after these requirements, the actual we can remind these things like short distance, easy construction and maintenance operation of vehicles, safe, construction and maintenance, economical, total cost. Okay, so this way we can keep in our mind that these things, 4 things: short, easy, safe, economical. After these requirements, the actual things which are in your syllabus, proposed syllabus, in highway alignment, that is factors controlling alignment. Which are the factors that are controlled your highway alignment and engineering surveys for highway alignment and location. So if we talk about the factors controlling alignment, under this factor controlling alignment, for an alignment to be shortest, as we know, it should be straight between two terminal stations. This is not always possible due to various practical difficulties such as intermediate obstructions and topography. It is not possible to keep straight the highway due to some obstructions and topography. A shortest route may have very steep gradients and hence not easy for vehicle operation. Sometimes a shortest route may have very steep gradients also. Steep, that is some hilly kind of surface, hilly kind of topography, very steep gradients, then not possible to construct a shortest route. Similarly, there may be construction and maintenance not easy for vehicle operation. Similarly, there may be construction and maintenance problems along a route which may otherwise be short and easy. There may be construction and maintenance problems along a route which may otherwise be short and easy. Roads are often deviated from the shortest route in order to cater the intermediate places of importance or obligatory points. Okay, so sometimes we need to, or we have sometimes such type of conditions can be arrived. Say some intermediate places are very important places, we cannot construct our road through this place, or some obligatory points, some river, some pond, some lakes. Okay, we cannot construct the road through these important points or obligatory points. So at that time we have to bifurcate our road construction or our alignment. Which are these process I am discussing? Acha, the various factors controlling alignment. First factors, that is obligatory points. Obligatory points are very important for theory questions. Obligatory points, actually, there are obligatory points: traffic, geometric design, economics, and other considerations like stability, drainage, geometric standards of hill roads, resisting length. So first, if I talk about the obligatory points, there are control points. Actually, what is obligatory points? There are control points governing the alignment of the highways. These control points may be divided broadly into two categories. Actually, these points govern the alignment. Actually, obligatory points means they govern the alignment of the highways. Which these points? Which these are? Point number 1: points through which the alignment is to pass. Okay, some rules there in obligatory points. The points through which the alignment is to pass. And number two, sorry, number 1, 3. And number 2, points through which the alignment should not pass. Number 1, points under obligatory points through which the alignment is to pass. Number 2, points through which the alignment should not pass. Obligatory number 1, suppose if we talk about the points through which the alignment is to pass, obligatory points through which the road alignment has to pass may cause the alignment to often deviate from the shortest or easiest path. That means the alignment of the road has been deviated from the shortest route. There is shortest route, but due to some obligatory points, some objection, we cannot construct our road through this alignment, thus through shortest path, and that's for why we have deviated our road. That the various example of this category may be bridge site, intermediate town, a mountain pass, or a quarry. Okay. When it is necessary, to cross hill range, mountainous or high ridges, the various alternatives are to cut a tunnel across, or to go round the hills, or to deviate until a suitable hill pass is available. The suitability of these alternatives depends on many other factors like the topography and site conditions and cost considerations. Suppose in figure A, this is this figure under points through which the alignment is to pass. Okay, alignment along a hillside pass. So as for this figure, we can say, when it is necessary to cross hill range, mountains or high ridge, the various alternatives are to cut a tunnel across, or to go round the hills, or to deviate until a suitable hill pass is available. The suitability of these alternatives depends on many other factors like the topography and site conditions and cost considerations. In this figure shows how the straight alignment AB, this is the straight alignment AB, is deviated along the hillside pass. Okay, thus avoiding a tunnel or heavy cutting. Actual road is AB. This is the actual road AB, but we have the shortest route AB. This dotted line is the shortest route, but due to deviate along the hillside pass, avoiding a tunnel, if we construct this road AB, shortest route, then there is required one tunnel or heavy cutting to continue this road A to B in this shortest route. But to avoid this cutting, this tunnel, normally the road is existing through this line, through this AB line. This is the actual road. Okay, this is some of one very good example of obligatory point through which the alignment is to pass. Okay, the road bridge across a river can be located only at place where the river has straight and permanent. Very important sentence, listen. The road bridge across a river can be located only a place where the river has straight and permanent path, and where the bridge abutment and pier can be properly founded. So where our river is straight, where our river is permanent, and where the pier or the abutment of the bridge can be constructed or founded permanently, at that position our bridge can be constructed for our roadway to pass a or to cross a river. Okay, in this figure, suppose the road approaches to this bridge should not be curved near the bridge, and as far as possible the skew crossing should be avoided. Always should be there straight line, no curve can be allowed at that position, at the entrance portion or exit portion of the bridge. Thus, in order to locate a bridge across a river, the alignment may have to be changed. Okay, in figure you can see, the figure shows that the straight alignment between section A to B. Suppose our two terminal station, this is A, this is B. Okay, I have to go A to B. which passes across the river bed. Actually, shortest route is A to B is this is, but is to be deviated along the path shown in order to cross the river at proper bridge location at the straight portion of the river on the upstream side of the band. So actually we could construct this along this AB line, this shortest route, but due to bridge we have constructed our road like this pattern. This is our alignment through which the alignment is to pass, not through this line, through this shortest line. This is the difference. The alignment through which is to pass, okay, like this road also. Suppose our two terminal station is A to B, we can go A to B directly this way, but due to some tunnel, due to some obstacle, or if we construct the road A to B in the shortest way, then we need one tunnel, lots of cutting, hilly cuttings. Okay, for that purpose we have constructed through this line A to B. Okay, and this is also one of the good example points through which the alignment is to pass. Our shortest route is A to B. This is this dotted line, but due to this bridge, okay, we can construct here bridge, but there would be the cost of the bridge construction will be high. But if we construct our bridge at this location, because this is permanent location, this is where the our river is straight and the abutment and pile can be founded very stable way. So we have proposed, or we have taken our alignment through this line. And also you can see at the entry point and exit point of the bridge there is no curves. Okay, vicinity of the this bridge, no curves is there, no gradient should not be there. Okay, and here also it is written that proper bridge location. This is the alignment to suit proper location of bridge. While aligning a road between two stations, it may often be desirable to connect some of the important intermediate towns, villages, or other places. Again, I am repeating, while aligning a road between two stations, it may often be desirable to connect some of the important intermediate towns, villages, or other places. Suppose in this figure, at this figure you can see the alignment to connect intermediate town. Suppose the straight alignment AB, our terminal stations are A and B, always our terminal station A and B. So suppose this AB, this straight alignment AB may be shifted along line ABC as shown in figure, in order to connect the intermediate station C. This is our intermediate station which is very necessary. Suppose A to B, suppose A is Durgapur, B is Asansol. Okay, we are going A to B, but in between C is one of the important intermediate station. Suppose Raniganj is one of the important location through which we have to go. Then our straight route is A to B, but to meet this intermediate station, to meet this important place, we have constructed our alignment through A to C, then C to B. This is connecting intermediate towns, and it is one of the important example of points through which the alignment is to pass. Another, you can see another example is there. It is also possible to connect the station C with a link road as shown in the same figure, as you can see, thus avoiding the deviation of the straight alignment. Also, suppose A is Durgapur, B is the Bardhaman. Okay, and at between these two intermediate station we have the I have told wrong. This, suppose A is our Durgapur, B is Kolkata. Okay, and in between these two intermediate stations we have one important place, that is Shaktigarh. Suppose Bardhaman. Okay, we can connect with a link road, our main road, our straight line, our shortest line. We can connect a link road. Okay, and this is called the connecting by link road. This is called connecting intermediate town, and this is called connecting by link road. And these are the example of points through which the alignment to pass and alignment to connect intermediate town. There is also another thing which I have told, that is points through which the alignment should not pass. What is this? Obligatory points through which the road should not pass also may make it necessary to deviate from the proposed shortest alignment. The obligatory points which should be avoided while aligning a road include religious places, very costly structures, unsuitable lands, etc. Again, the it necessary to deviate from the proposed shortest alignment. It may deviate. The obligatory points which should be avoided while aligning a road include religious places, very costly structures, or unsuitable lands, etc. Religious places like temple, mosque, church, grave, or tomb have been protected by the law from being acquired for any purpose. Okay, we should avoid any place like temple, mosque, church, grave, or tomb, which have been protected by law from being acquired for any purpose whatever. Acquiring costly structure would mean heavy compensation resulting in increased cost. Costly structure also, we should avoid costly structure. Suppose monument, through monument we cannot construct any road. Suppose through any kind of structure, historical structures, costly structure, heritage structure, we cannot demolish this structure. We should avoid such type of places or structures, and this is the point through which the alignment should not pass. Like also there is marshy, PT, and waterlogged areas are generally unsuitable for road construction and should be avoided as far as possible. However, if there is no alternative and the alignment has to be taken across such an area, the construction and maintenance costs are likely to be very high due to special construction techniques and drainage measures to be adopted. So if you have need to construct, somehow you have to construct the road through any costly structures, through any costly area, then some special considerations, some special techniques are needed for your construction technique. Suppose you can see, this is one of the pictures. Suppose alignment avoiding an intermediate area, suppose lake. This is also one of the picture. This is the lake, or we are avoiding this lake through this line, through this alignment line A to B. Okay, next is a lake, a pond, or a valley which falls on the path of a straight alignment will also necessitate and the alignment to be deviate from the straight path and go round along the grade line as shown in figure. After this, we have these points, geometric design. Okay, geometric design under the alignment of highways. This geometric design just for information, no calculation, no terminology which are normally being used for geometric design is involved in this section. So it is the just factor controlling alignment. Geometric design factors such as gradient, radius of curve, and side distance also would govern the final alignment of the highway. Okay, obviously radius of curve, straight distance also we will discuss broadly after 1 and 2 class. Okay, geometric design, we will start the geometric design. If straight alignment is aimed at, often it may be necessary to provide very steep gradients. As far as possible while aligning a new road, the gradient should be flat and less than the ruling or design gradient. I can see you one picture of gradient, just wait. Just wait. I'm searching. Yes, I got. Just wait. This is actually gradient. Okay, this is rising gradient. This is falling gradient. Okay, and in geometric design, we should take care about this gradients. Okay, or vertical curve, horizontal curves. So lots of things are involved in geometric design. So what I have said in geometric design section. In geometric design section that if straight alignment is aimed at, often it may be necessary to provide very steep gradients. As far as possible, while aligning a new road, the gradient should be flat and less than the ruling or design gradient. Ruling means which is permissible, which gradient or the gradient value, the slope is permissible for particular road, that is ruling gradient. So the ruling gradient or the design gradient which is permissible, and it should be flat. Okay. Thus, it may be necessary to change the alignment in view of design speed, maximum allowable super elevation, and coefficient of lateral friction. All these things will be discussed in your geometric design section. So I will not talk about much more about these things. So it may be necessary to make adjustment in the horizontal alignment of roads, keeping in view the minimum radius of curve and the transition curves. Okay. Also, what is curve? What is transition curve? Already, I don't know you had in your survey lab or survey engineering, but again, as a requirements of the highway engineering, you should have good soil mechanics knowledge, you should have good soil survey, because our highway engineering normally the company actually it is the composition of the 3 or 4 subjects like your survey, soil, concrete technology, concrete technology lab, soil lab, highway lab. These things are should be very clear to you for transportation engineering. Some theories of surveys are involved in geometric design. Some tests, some experiments of soil mechanics, as well as some tests of concrete technology, which are normally used in our highway engineering. So, highway engineering one of the application subject of civil engineering, which are taken from the basic subjects, but it is especially important to construct our highway or to control our traffic or to maintain our transport. This is very important to us. So the absolute minimum side distance which would invariably be available in every section of the road is the safe stopping distance for fast moving vehicles. Also, there should be enough distance visible ahead for safe overtaking over observation of vehicles moving at design speed on the road. Hence, the alignment should be finalized in such a way that the obstructions to visibility do not cause restriction to the side distance requirements. Also, the what is side distance we will got from the geometric design. What is side distance? What is stopping side distance? What is safe stopping side distance? Okay. The details of geometric design factors already we will study, no problem. Next is economy. Okay, economy. Should be economy, not economics. Economy. Economy. The alignment finalized based on the some factors like which we have discussed should also be economical. Okay, the alignment always not, points to which the alignment is to pass, points to which the alignment should not pass. This is not enough. Alignment should be economic also. Okay, and for that purpose, the in working out the economics, the initial cost of maintenance and the vehicle operation should be into account. Okay, initial cost of the construction of the road and the vehicle operation cost should be taken into consideration. The initial cost of construction can be decreased if high embankment and deep cuttings are avoided and the alignment is chosen in a manner to balance the cutting and filling. So if your cutting and filling of earthwork of road is balanced, then your economy also or economical value will be less, or the economy should be balanced. Your economy should be balanced. If your cutting and filling both are balanced, then your economy would be balanced. Cutting means cutting for road work, filling for road work to maintain the formation level. Okay, in survey, in profile level survey, in leveling survey, you have studied, I think, what is the formation level, what is cutting, what is filling. Okay, other consideration. Under the other consideration, there is stability, drainage, geometric standards of hill roads, resisting length. So if we talk about the details of the other consideration, the various other factors which may govern the alignment are drainage considerations, hydrological factors, political consideration, and monotony. The vertical alignment is often guided by drainage consideration. The surface water level, seepage flow, and high flood level are the factors to be kept in view. So already I have told that moisture is very harmful. Moisture is enemy for road. Moisture is enemy for highway. If moisture is if there will not be the moisture, then our road is highly durable. Okay, if moisture is present, road is less durable. So where the intensity of rainfall is very high or humid area, the lasting of the road is very less, and where the humidity is less, rainfall is less, the durability is very high. This is the relation between road and moisture or water. Okay, so is the construction of the road as well as the maintain the alignment, drainage consideration, hydrological factors, political considerations also, and monotony. The vertical alignment is often guided by drainage considerations. The surfaces water level, seepage flow, and high flood level are the factors to be kept in view. A foreign territory coming across a straight alignment will necessitate deviation of alignment around the foreign land. At times, the alignment is decided only the strategic consideration. Foreign territory means the foreign land. Roadside lane, border side road. When we construct the border side road, then we should keep in our mind that which is the foreign territory, land. Okay, otherwise it is very difficult to maintain. Otherwise, it is very difficult for on various considerations or various aspects like political aspects, diplomatic aspects. At times, the alignment is decided only the strategic considerations. In a flat terrain, it is possible to have a very long stretch of road absolutely straight without horizontal curves. But straight road of very long stretch may be monotonous for driving. Very important sentence. Straight road of very long stretch may be monotonous for driving. Hence, after a few kilometers of straight road, it may be desirable to have a slight bend to break the monotony and keep the driver alert. So, it is also not desirable to keep our road continuously straight, continuously stretchable. So sometimes after few distance there is no prescribed value after how kilometers we can provide any bend or any curve to break the monotonous of the driver. Okay, and some special considerations while aligning the roads or hilly areas. uh, Under these special conditions, there is stability. While aligning hill roads, special care should be taken to align the road along the side of hill which is stable. Common problem in hill roads is that of landslides. The cutting and filling of earth to construct roads on hillside causes steepening of existing slopes and affect its stability. Drainage. Numerous hillside drains should be provided for adequate drainage facility across the road, but the cross drainage structure being costly, attempts should be made to align the road in a such way where the number of cross drainage structures are minimum. Cross drainage structure means your river side, your canal, your drain. Number of drains, number of canal, number of river, number of your bridges, number of your culverts are required, and cost is high. Your highway construction cost would be high, your road construction cost would be high if number of rivers, number of drains, number of canals are in your way. Geometric standards of hill roads. Different sets of geometric standards are followed in hill roads with reference to gradient, curves, and speed, and they consequently influence the side distance, radius of curve, and other related features. The route should enable the ruling gradient to be attained in most of the length, minimizing steep gradients, hairpin bands, and needless rise and fall. These are some things which is important, but in this section it would be not clear to you. So just listen the names, the side distance, radius of curve, and other related features. The route should enable the ruling gradient to be attained in most of the length, minimizing steep gradients, hairpin bands, and needless rise and fall. Okay. Resisting length. The resisting length of a road may be calculated from the total work to be done to move the loads along the route, taking the horizontal length, actual difference in levels between two stations, and the sum of ineffective rise and fall in excess of floating gradient. In brief, the resisting length of the alignment should be kept as low as possible. Thus, the ineffective rise and executive fall should be kept minimum. So, rise and fall already in geometric standard also, geometric standard of rise and fall should be should be reduced. Needless rise and fall or the ineffective rise and fall in excess of floating gradient should be reduced. Thus, the ineffective rise and effective executive fall should be kept minimum. The detailed consideration of hill roads alignment should be discussed in detail in your geometric sections. For today, I'll stop here. Just wait, I am taking your attendance from software. So thank you, all of you. Uh, okay, okay, you can leave. Hmm. Okay, you can leave. Hmm.